again, if people are not familiar with TDD, it's one of the most important aspects of it is starting red and seeing it go to green. And I, like probably many people who've done TDD over the years, when I first started with it, I remember a few months in, I kind of thought, oh, well, I've mastered this now. I've got to grips with it. So I don't need to do the red step anymore, right? Because I get it now, you know. And I started not doing the red step after a few months, and it bit me very quickly. Very quickly. I think within like a couple of days, there was a test that didn't fail where it should. I see a lot of noise online where a lot of people are saying, oh, AI just doesn't work at all. It's just, you know, it's all hot air. And other people saying, oh, well, the solution to AI is basically going back to pretty much waterfall, and it's big design up front and you have to get all your specs right again. And then there's people like me who are doing the exact opposite and saying, no, actually, if you try using XP, it just, you know, these techniques, it massively accelerates you.
Hello and welcome to Hot Tech. This is a new format we're trying out in which either me or a guest will come with a hot take and we will talk around it for an hour. Today's guest is Paul, and Paul claims not only that he can do TDD on the front end, but also that it is integral into how he uses AI to code. Before we start discussing this bold claim, if I'm allowed to say so, let's meet Paul. Paul, could you introduce yourself in 3 sentences or less, please?
I'll try. I've been in the industry about 20 years. During that time, for about 13 of those years, I've been doing test-driven development, both on the front end and the back end. And for the last, well, as of recording now, we're on, this is like we're mid-March, and I haven't written any production code, either personally or work-wise, without AI since about November last year. And all of that has been very TDD-based. And I'm, happy to discuss this as much detail as you want. Probably went over 3 sentences, but tried.
No problem. I'd like to dig in first with the TDD aspect, not because it's less important than the AI aspect, but because at least in the front end, they've never managed to actually implement TDD. And when I've discussed this idea of an episode around me and with people in my network, the front end TDD was always met with disbelief. Without trying to challenge you too much, but can you back up the claim that TDD in the front end is actually possible?
Yeah, not only is it possible, it works brilliantly. It's like it's a really nice way of working. So I guess for some context, if just to put things into context a little bit, and then I'll talk specifically about front-end TDD. It was around 2013, I think it was, when I started doing TDD for the first time. And that was when I joined, at the time I was joining the BBC. I worked there for about 4.5 years at BBC Sport. They said as like part of the job requirements, they wanted people who knew TDD. So I started, the period between jobs, because I've been offered the job, I found myself reading up on test-driven development quite heavily. And I watched a video called TDD, Where Did It All Go Wrong, by a guy called Ian Cooper. For people who are not familiar with that talk, he basically says, look, a lot of people try test-driven development. They don't have the same success that some of us have, and they think that, it's all hot air, it doesn't really work. And he basically says one of the main reasons for that is because a lot of people get fixated on this idea of what is a unit, right? So they think a unit is a block of code, it's a function, it's a method, that kind of thing. And because they want to test this unit, which they think is a block of code, in isolation, what they do is they mock out all collaborators to those units. So, you end up with this tests that are very tightly coupled to implementation details. Every time you change some implementation, your tests start failing not because the code is actually broken, but because the actual underlying implementation has changed. And he said that's a problem. So what he says in his video or in his talk he says you should consider a unit to be a unit of behavior. So test behavior, not internals, right? So when I started there, I was doing back-end code for the majority of it. So I've spent about 50% of my career doing back end stuff, and then about another 50%. But I'd say either doing front end or a mixture of both, right? But very heavy on the front end for quite a long time. So I started with for my sins, people laugh at it because it's PHP, but I did a lot of PHP back then. The BBC was the back end was all PHP back then. It's not anymore, but it was back then. So I was doing TDD based on behavior on the back end, right? And it worked extremely well from the get-go, right? And I found that by testing behavior, not internals, I was able to do these kind of refactorings that were just extremely, actually very satisfying. I had this setup where I would have like two monitors, and on one screen I've got my implementation code, on the other screen I've got my tests, and I'll always run my tests in like a watch mode, right? And as soon as I change code, the tests run. And so if I break something, which would happen often, I'd usually find out in a second or two because my test suddenly failed. So anyway, what happened was I had a great deal of success with this in PHP world for a while, and then the BBC were very early adopters of React. So we started. It was pretty soon after the very first public release of React. So it was still on like 0. whatever it was back then, like 0.17 or something like that. But I had already got into this kind of TDD mindset because I was finding it so satisfying to work with. I kind of got involved in the early stages of the React stuff going on there, and straight away I cared about tests, right? And I cared about the not just tests, but how do I go test first, right? The landscape was quite different back then. We still had tools that were capable of helping us with it, and we managed to make it work even back then without all the tools that we've got today. So from memory, I think we had a setup where we were doing something with we had a headless browser. I think Phantom was the name, Phantom, back then. But even back then, I applied this philosophy that so people who remember the earlier days of React might remember that there was a testing framework. I've forgotten the name of it. It begins with an E. I should remember this, but it heavily encouraged people to test in implementation details. That's a problem. So if you know React, it would have you shallow rendering all the time, right? And I didn't like that, and because to me, shallow rendering. So again, people are not familiar with React maybe on the front end because these techniques should work for any framework, right? But I was coming at it from a React perspective, but one of the kind of classic problems if you're doing shallow rendering, so if you imagine you've got a React component, the way that components work in React is they're all supposed to be composable, right? So if you're building a big feature, you might have multiple components that you compose together to build this bigger component or bigger feature, right? The way that a lot of people, certainly back then, and still even now, I think, kind of think about this stuff is I have to test all these individual components in pure isolation, and you almost forget that you have to kind of bring it together, or you do the tests that bring the components together. Usually people call them integration tests. You do them as a separate piece. But where I came from, I started from a very different perspective, and I was like, no, what I want is tests that are based on behavior all the way through the stack, right? So I didn't, from the very early days, was not doing shallow rendering. In fact, I've never written a React test. And bear in mind, I've been using React since, as I say, like the 0.17 days or whatever it was. I've never written a single React test that was shallow rendered, like ever. Enzyme, sorry, that was the name. That was the name of that library. It was Enzyme, and Enzyme used to basically encourage people to do that. And I was quite well known at the time at the BBC for somebody who wouldn't allow that kind of style of testing. And at the time, that's quite controversial. People didn't really agree with it, and I was told it was wrong constantly. Quite satisfying in a way that React testing library came out later, which basically forced you to do it the way that I think produces better results. And then suddenly everybody who previously told me I was doing it wrong they were all saying the same things. And, it was all like, oh no, this is a best practice. And I was like, yeah, I know, I was doing it 3 years ago. Do you know what I mean?
Yeah.
But yeah, hopefully it gives some context, but we can go into the detail if you like. I mean, in the front end space, we have some really good testing kind of tools now. So for a long time, I was using Jest, and Now I tend to use vtest, but they're quite similar in a lot of ways. The structure that I always go with this stuff is I'll use tools like React Testing Library, which I think is an excellent library. What I really like about React Testing Library is that it basically forces you to test in a way that is similar to how a user would interact with components. So if I'm building, I'm trying to think of an example, but like, I don't know, I'm building. What will often happen is you sometimes have components that can legitimately exist in their own right, and that might have reuse value in different contexts, right? But then you also have components that sometimes you're building as part of a bigger piece, and they're very specific to that use case, if that makes sense. So the way that I can kind of write tests, it's always based on behavior. So there's always a discussion with the business before we start. I always have very clear acceptance criteria before the work begins. That doesn't mean that it's all rigid, because you discover stuff as you go, and stuff you can chop and change. But it's very based on, if you read Dan North's original article on BDD, behavior driven development, he always basically said that BDD is just TDD done correctly. Basically, that's all it really is, right? And this is what he was saying originally, and that the idea is that you just base your tests on behavior, right? I'm aware that I'm talking for a long time. I don't know if there's anything you want to specifically ask me or anything, and we can go into any detail.
It's fine. I am taking notes because there are some highlights that I want to come back afterwards. But no, I'm more than fine with you talking.
Yes. So a few things to bear in mind, right? So typically on the front end, one of the issues that you get is that you've got the visual aspects, right? So you've got the look and feel as well as behavior, because you also have behavior associated with components, right? So one of the problems that you have straight away is how do you deal with that, right? And it's a common complaint from people who maybe are less experienced with it, don't know how to do this very well, is every time the design changes, I'm scared that my tests are going to fail. So we can talk about that. React Testing Library helps straight away with that in a really significant way. One of the things, and I should be clear, sorry, I keep saying React Testing Library. It's actually a testing library suite, right? And React is, it began as React Testing Library, but Kent Dodds, the guy who made it, he came up with this idea of, eventually it was refactored to be, it's under the hood, it's DOM testing library. And then you just have these kind of thin layers on top. So you've got like a React one, you've got Svelte one, all this kind of stuff. I think there's an Angular one and so on. One of the things that's very powerful about that library is that it has these very nice selectors. So if you think about how a lot of teams write front-end tests, they'll do things like, you've got to be careful to not have your test bound to the structure of the HTML unless that actually matters, which it does in some cases, because there can be accessibility related concerns. So for example, if you have a label component that needs to be associated with an input field, the actual structure of the HTML matters there, because if you do it incorrectly, then it's not accessible, won't work with screen readers and things like that, right? What the testing library suite has is this really powerful set of selectors that are based on there's a kind of order of preference to them. They've got this in the docs. I might quickly Google that and read it out in a sec. But essentially, what they do, so they prioritize things like get by role, which is an accessible selector, or one of my favorite ones is get by label. I think it's get by label text, if I remember off the top of my head. And what that will do is it will get if you wanted to say type in an input field, you get that component not by selecting directly in the DOM as well, not by selecting specifically for like its position in the DOM, or by using XPath or anything like that, or CSS. You do it by the kind of the association from an accessibility point of view with the correct association with a label, right? Now, I'm just going to quickly Google this. So it's a testing library. So I guess if people want to try this themselves, I'm typing testing library, selector preference, I think, priority. So selecting library, testing library, select a priority, and if you go in, there's a queries. Trying to find it now. There's a page here somewhere. There you go. So I found a page which is it's got about queries at the top, and there's a priority click, right? So if I click on priority there, queries accessible to everyone, right? So sorry, there's a number of, so 1, 2, 3, 4. There's an actual ordering of these selectors. So get by role is seen as the first one, and I'm not going to read them all out, but it says, for example, this can be used to query every element that is exposed in the accessibility tree. With the name option, you can filter out the returned elements by their accessible name. So you can, what these selectors do is they give you a way of quite easily selecting elements that are both that will implicitly fail the actual selection if they're not accessible. So that's one thing. So it kind of gives you that boost straight away. But also, they're not bound to the position of elements in the DOM, except where that matters, as I say, for like accessibility reasons. And they're not bound to CSS, right? So they're not bound to the look and feel. So I actually gave a demo some time ago. You can still find it on YouTube. If you search for, I think it's Tech Excellence is the name of the group, and Tech Excellence TDD, I think you'll probably find it, or my name on there. You'll find a video there where I gave a bit of a demo of, how to do TDD on the front end. I mean, that was part of the talk. It wasn't the whole talk, but I demoed that a little bit. And one of the things that I demoed in that talk was I showed having, you can see a HTML page, which has got styling on it. And then I deliberately just moved components around, including inside inside and outside of DOM structures on the page, different divs and so on, and showed how the tests continue to pass as long as the behavior worked. But as soon as I broke the behavior on the page, the test failed, right? Now, to be clear as well, I advocate for explicitly using the DOM, right, to test again, as in do render the component in the DOM, use these accessible selectors. This is something that a lot of people who are very pro TDD and have done TDD for years, it's quite, well, as you know, because you're asking me these questions, it's a very back-end dominated kind of technique, right? Most of the people who've done it see the front end as like, almost like an annoyance, like, it's annoying that that's there, but we've got a good setup for the back end, right? Often you'll find them telling you, don't test things through the DOM, because they'll say it's slow and it's brittle, but it's not, and it hasn't been for a long time if you know how to do it. So tools like Jest and vtest also give you access to a virtual DOM. So the virtual DOM is an in-memory representation of the DOM that doesn't actually need a full browser to render, and is quite so you can do a lot of this stuff without even opening up in the browser, right? And the tests are remarkably fast. The other thing as well to mention is that quite new, this is fairly hot off the press actually, vtest has a browser mode now, which allows you to actually do this same style of testing in a browser, but it's remarkably fast, like extremely fast. If you're interested, I can send a screenshot of, because I'm building I've got a personal project that I'm doing with AI right now in my spare time. And at the moment for that, I have just under 1,000 front-end tests right now, just under 1,000. And the whole test suite runs in about, I think it's about 19 or 20 seconds for about 1,000 tests. And also, and I can show you a screenshot of that, like, because you can see it, And the other thing is day to day, the way that I do it normally, if I'm not using AI, but we'll get to that in a bit because I am using AI. But if I was doing it outside of AI, I always have my tests in a watch mode. And the front end tooling now is quite intelligent. The way that it kind of works is if you run in this watch mode, it's intelligent enough. It can analyze your source code and it can see when you edit this component here, that's going to require me to run these exact tests, right? So it will only run the tests that are needed for that change. And so that means even if you had 20,000 tests and it took a minute to run them all, which it'd probably be faster anyway. But regardless, I don't know actually, but regardless, you just day to day was during development are running a watch mode, and therefore they're always fast. Do you see what I mean? So like again, I get into this position where I can change a component, and if I break it, I find out in seconds that it's broken, right? And I'm extremely used to having an extremely high level of confidence with both front end and back end code, to the extent, and the mental model that I have is, and I've had for some time now, is if the tests go green, you should be able to take it absolutely literally, and I mean literally, black and white, that you can go to production with that. And if you don't have that level of confidence, I'd say that's a problem, and you should look at that. And that ties into AI as well. And then I think, but because I've kind of taken this stuff, and now I'm like, okay, how do I get that same confidence in AI? But before we go there, like, feel free, you can ask me any questions.
Yeah, I was gonna say I do want to dig into a couple of things before going to AI, because I do agree that that level of confidence is needed with AI, and I've seen a lot of what you've written about mutation testing on top of the TDD loop. But I wanted to come back. The first question is the last one that I've written, but you say that you have about 1,000 tests in about 19 seconds, something like that. How much of that is a setup cost, in the sense that even if they are on watcher mode, you have, I don't know, 3 seconds that are immutably paid every time they run? Or
no, that's 19 seconds from the moment I run them. It's funny because obviously this is a podcast, so nobody else can see it. But you can always explain what you can see, and this is probably where it goes horribly wrong because I'm sharing my screen now. But let me. Is this okay? Is this good?
I am not seeing your screen right now, but yeah, it's good to do this, and I can vouch if it runs in the quote unquote correct time.
Yeah. Okay. So let me just do this now. I'll share my screen, and let me just. So you should be able to see. Yeah, you can see this, right? So hopefully I'm in a place where this would work. I didn't exactly prepare this, so let me just. Hopefully it's all good. If I do. Oh God, what is it? Test UI watch. So I put it in a watch mode, but if I do it in watch mode here, oh, hang on, it's going to pop up on my other screen, but I'll just move it over when it starts. Hang on, here it goes. Oh, no, you can see it. So now you can see them running.
That's fast.
Yeah, and if you see here, now it's funny, well, just watch the time in a sec. It should be about 20 seconds, roughly. It seems to just suddenly jump because it's on about 300 now. And then maybe we're going to go slightly over. There you go. So you can see, okay. Oh, it said 30 seconds. But okay. Well, I mean, it's funny because it was reporting 20 or so seconds, but then what it's actually reported on the screen, so it's 962 tests in 31 seconds, which actually seems slower than I was expecting. But
yeah, what's great is that although it really flashes because the tests are really, really quick, you do get to see what's happening on the browser as well, which is interesting because one of the things, like, I do TDD mostly on the back end because I don't know how to do it on the front end, right? Like, all of the problems you say that people have, I have. They are brittle. I don't know what to test. I don't know how to test. I don't know where to start. I don't know. It's slow. I don't know where to put the boundary. A lot of things. And I'm more comfortable doing that on the back end because for reasons I'm better able to identify, okay, this is a seam that I want to test, and this is just something that is behind the seam and does not need testing, or I am adding tests whilst I'm developing and then taking them away because they're not needed anymore, stuff like that, right? But seeing it here, and I will probably ask you for a screen recording of those tests running if you're comfortable, so I can append it to either descriptions or whatever, so people get to see it as well, because it's quite impressive that first, like 1,000 tests in 30 seconds is impressive in and of itself, but also the fact that you get to see, okay, you can get a feel of, okay, my browser is behaving as it should, and it's not only the tests that are saying it's green, I can also kind of see if there is a problem there or not, right? I would like to come back to an adjacent topic that you said. So at some point you started describing BDD, and so I wrote BDD, and then you explicitly stated that you're doing BDD, which is according to the person who revealed BDD to the world. I don't know how to describe these ideas, or the people that first talk about these ideas. It's the correct way of doing TDD. I think that trying to do BDD in the front end is what's holding me back in a sense, because BDD has a lot of things that are associated with it that are not really BDD, but like you want to have given when then, even though I know that that's not what you should have. But
Yeah,
you talk to
so
business and you want to give them a language that they can understand, so you reach for gherkin because it's there, and it might work even though it doesn't, and like
yeah, to be clear, so I should be clear on this one. When I talk about BDD, BDD, I think, is one of those things that in the industry, there are these terms that have a kind of clear meaning when they're first communicated, and then the industry gets a hold of them and commonly just misunderstands the meaning, and then the misunderstanding becomes the general belief, if that makes sense. So, like, for example, continuous integration is a classic one, where people think continuous integration is a server, and that's not what it is at all. It's, continuous integration is the act of multiple people merging their code into a shared mainline multiple times per day. That's, you can do it without a CI server, and you can also not be doing continuous integration with a CI server, right? BDD is one of these other ones where people have completely misunderstood it over the years, and it's become known as, widely people think BDD is just given when then and using Cucumber, and it's not that at all. I should say that I actually detest Cucumber with like the passion of a million white hot suns. I can't stand it. I've used it many times before, and I don't think it works. I think the ideas behind it were good ideas. The idea being that the idea is supposed to be that you close the gap with the business by encouraging this communication, which I think is a really good thing. And then that you're supposed to have this kind of language that is shared between the business and the developers, and the tests themselves execute these exact specifications, right? The problem is that the actual technical side of mapping plain English, to test, it just doesn't work in practice, in my experience, and it just becomes a nightmare very quickly. So for me, it's funny because I've been saying for years I think I do BDD because I test based on behavior. Loads of people again told me, no, that's not what it is. It's you have to use Gherkin and all of this stuff. And then Dan North on LinkedIn, so he's the guy who came up with the actual term BDD. I think I at some point I pointed this out and I said, oh no, I think I'm actually doing it. And he actually responded to like a comment I'd put somewhere. And he said, yeah, that's what it originally meant. It was always supposed to be based on behavior, right? So the way that I see it, so the way I apply it in practice is I absolutely do have these conversations with the business, first of all. And I think that's to me is the most important thing, right? And because it's just so common, and like in the place I'm contracting at now, they do use Gherkin in the acceptance criteria, in tickets and so on. And I'm kind of okay with that, as long as we don't actually write the tests mirroring that language exactly, because I just find that's where it breaks down. So I don't do that. So what I do is my tests are all based on, I don't know if there's a specific name for this style, but it's, if you look at like Jest and VTest, typically it's like this kind of it should format. So I'll take, So like if we say, if the acceptance criteria, it's going to be, I'll probably mess this up coming up off the top of my head now, but if it's a modal, right, on the front end, modals have a specific behavior that you have to do for accessibility. So one of those is called a focus trap. So when you open up a modal, if you tab through all the elements in the modal and then you keep on tabbing, it should come back into the modal and keep tabbing inside the modal, right? If it doesn't do that, that's an accessibility problem, because the focus has gone outside of the modal, but the modal is still blocking the actions on the page. And if you're using a screen reader, You wouldn't know. So if you had given a user is tabbing through, given a modal loads up on the page, when I tab through all the elements and reach the end element and hit tab again, then the focus should stay within the modal, right? The acceptance criteria said something like that. I would convert it under the hood. So what I tend to do is I'd say, okay, so there's a context there. So the context is the modal is open, right? So then what I might do in tools like vtest and Jest, you can do nested describe blocks. Now I don't do that too much. I don't like nesting too much, but sometimes I'll just do a little, like one level of nesting, just because then I'll have like one that says describe, modal is open, right? So then you just nest the test for when the modal is open inside that, and it'll just be, the focus should remain within the element when you scroll through it all, and scroll to the next element. Do you see what I mean? And then I'll have a test that just does that. So, but the key thing for me there is that it's really the discussion with the business. It's making sure that you are really clear, and because the tester, this is the interesting thing, right? So say under the hood to make that happen. In React, maybe I'm using a custom hook, right? Or maybe some other method, and I've got some function under the hood that basically is aware of, okay, I'm inside a modal, the user is tabbing inside this modal. When they get to the end of this, they get to the last element, hit tab again, goes back to the first element in the modal, right? The interesting thing, when we talk about behavior, not internals, I won't have a test directly for, if there's a function that's doing that under the hood or a hook, I won't test that directly. I won't even test a React hook directly there. What I would do instead is at the level of the test where you're testing, rendering in the DOM, I'd simulate exactly as the user does it. So as you've seen just now, the test pop up, and I'll record the video so you can share that, so people can see a video of that happening. You would actually have a test that just simulates the user tabbing, and then you see that the focus goes to the first element again, right? How it works under the hood is irrelevant. The test shouldn't know or care. So if you work in that way, say if I start with a custom hook, the test will pass as long as that hook works and is applied correctly. But further down the line, let's say I look at it and I'm like, oh, I don't even need a custom hook for that. Or I can use this library that's better for some reason. I'll use this library instead. But say I refactor to use some other library and I break that functionality, the test will fail because it's not, do you see? But if it works, the test will pass. And so I'm very careful about where the line is. Now, to be clear, if you wind back and say, okay, say if I'm writing a custom hook to do that, you might say, okay, but that custom hook has reuse value. Maybe that could be used in other contexts, right? So therefore, maybe it should have its own tests, right? That's where I would, to me, where you have to kind of apply a bit of thought. And I would say, okay, let's say that custom hook has reuse value elsewhere, or these other projects that could use it. In that case, then I would test it in isolation as well. But even then, the way I test a hook, see, there's in the React world, there's a way of testing hooks where you go into the implementation details, and I don't like that. So the way I would do it is I would actually write a component in the test that consumes that hook, if that makes sense, and then just prove that component behaves as it should when it consumes it. And the other thing as well, just to add, is I would tend to do, I'm quite a fan of Storybook, so where you can, if you're familiar with Storybook, it's like a, I don't know if you call it a framework or a library, but it basically allows you to render these components visually in isolation, and you can put them in any state you want so people can see those, and it documents all that stuff. So I typically, in a world where, say, you're building a reusable hook like that, I might have a Storybook story somewhere that shows that being used in different contexts as well. Does that make sense?
It does make sense. I think the pattern you're describing is called the describe it pattern, but I'm not sure.
Yeah.
In the Ruby world, which is where I come from, it's the one used by RSpec as opposed to Minitest, which is kind of the default for Ruby testing. And the way they handle this internals testing, in the sense that I have a module that helps me do X. and it doesn't make sense to test it in isolation, but I don't want to add the testing code to every component or every class that uses it. We have shared hooks that we can put, and it behaves like something, right? It's something you can just hook in your other examples and say, okay, this user class behaves as if it's loggable, and so it has logs, and it will just test that, okay, these tests that are testing the logging capability are applied to user and to teacher and to student, and et cetera, et cetera.
Yeah, one thing just to mention on the kind of describe it kind of thing as well is that I am quite strict on that. Like, I don't like that in general. I don't like nested code anyway. Like, I don't really write else statements. I don't like those, and do you know what I mean? I don't really like nesting. But I'm when it comes to describe blocks, I pretty much go one level deep, and it's just a group test really. That's the only reason, But I wouldn't recommend going too far with it, because you'll it gets a bit messy if you go too far.
Yeah, it's the classic issue of I don't know where my context is coming from because it's inheriting from 5 different nesting levels and
exactly
whatever.
Yeah.
I'm gonna close the TDD chapter, although I know it's quite tied to the AI chapter because it's been already 40 minutes, and I would like to talk about the other part. I have one question about the AI part that is tied to something you shared before, in which you had your setup with 2 monitors. One has the tests that are on watch mode and one has the code. Is your setup with AI similar?
Not exactly. What happened with AI was, like a lot of people, I'm sure probably all devs have experimented with it. And I was playing about, especially in what little spare time I have. I mean, I have 2 young kids, but where I could, I was playing about with it. And I found that initially, the way I've described it before, it was a bit like an interesting kind of parlor trick, is the way I describe it, where it was, it seemed quite powerful, but it was actually not really too applicable or too useful, because what I found straight away. So you have to remember, I'm coming from this world where, even if you haven't experienced it, the only thing I can explain to you on this one is that when you do TDD properly, and you don't cut corners, and you really do, you really invest in it and you do it properly, and I do it for both front and back end, you can get in this position where your confidence really is so high that when your tests go green, you do feel like you can go to production, right? And you can come back to code that you wrote 2 years ago, and it's like, oh, do the test pass? Yes, good. I know that they were written that way, so I'm good, right? And I've experienced that recently, actually, coming back on a project that was written a couple of years ago. So when I started with AI, I felt like I'd instantly lost that, right? Because one of the first experiences I had was I asked it to do, I can't remember what I asked, but like I asked it to implement something, and it went and it just did too much in one go. Like it just did, like, it did the thing that I asked it to do, but then it did about 15 things on top of that, and it was just all over the place. And I found that I was having PRs that were huge, and I couldn't control them. I didn't understand exactly what's happened. I don't trust the tests anymore. I'm suddenly in this position where it's like I don't want to have to go in and manually click on stuff to see that stuff works. This, to me, it's like that's ridiculous. It's like I'm coming from 13, 14 years of not doing that, right? And literally not having, not doing manual testing. The only manual testing I tend to do is when if you update a design, you need to physically look at it. Do you know what I mean? That's it. But even then, most components tend to be reused, so you tend to not have to do that very often. So what I started doing with AI was I built my doc files, which I think you're familiar with the doc files that I created. Mm-hmm. Yeah. So again, I can share them, and if you want to put it in your notes, that's all good. I started by I thought, well, let me try and get it to work in a similar way to how I work without AI, right? So one of those things is test-driven development. Now, people might think, okay, but why does it matter? Do you know what I mean? Having AI do TDD. But quickly I found a few things started happening the moment I started forcing it to go in a test first way. So I'd say there's probably 3 things that really stand out to me. So one is that it restricts the scope of what the AI is doing, because you tell it your job is to make the test go from red to green and then stop, right? And let me check. So I guess this is the first part of answering that question you're asking me. Rather than having like a terminal with the test running and, an ID or whatever, it's more that my flow is slightly changed to I get AI to go red, green, refactor. It's actually red, green, refactor mutation test now, but we'll talk about that in a sec. But then that also serves as a kind of natural stopping point for me to check. And then I'll just go in and I'll just check. And the main things that I check are, are the tests actually good? Are they testing behavior, not internals? Is it testing the right stuff? But you make it work in these smaller increments and it's easier to double check these things, right? So I guess first thing that it did was it made it work in these kind of in this more kind of constrained way. The second thing, it gives the AI a way of proving that what it's just done has worked, right? To a point, right? You still have to check the tests. You still have to make sure that they're good, but it sees the test go from red to green, right? Now, again, if people are not familiar with TDD, it's one of the most important aspects of it is starting red and seeing it go to green. And I, like probably many people who've done TDD over the years, when I first started with it, I remember a few months in, I kind of thought, oh, well, I've mastered this now. I've got to grips with this. So I don't need to do the red step anymore, right? Because I get it now, And I started not doing the red step after a few months, and it bit me very quickly. Very quickly. I think within like a couple of days, there was a test that didn't fail where it should. Do you know what I mean? And so I was like, okay, that's why you should be doing it. So the act of seeing it go from red to green helps AI as well. And then the third thing is that you end up with this regression suite. If you're careful and they're well written, you end up in this similar position to what I was used to without AI, where you want that confidence, the test pass on good, right? Now, that's where I'm kind of working. Now, to be clear, I don't want to make this out like it's absolutely 100% perfect every way. You still have to check stuff. I still do check. But by and large, it's worked extremely well for me. One thing I will mention is when I do it, there is one thing that's slightly different. Well, actually very significantly different to how a human should do TDD, right? Because TDD is always one test at a time, right? Because you get yourself into this rapid feedback loop, right? So as a human developing the system, it's always one test failing, make it pass, see if there's any opportunity to refactor, and then repeat, right? What I found with AI, initially I made it do that, and it does work. It seems to work quite well. But I thought, I'm going to be open-minded. I'm going to test and just play about with stuff in my spare time. And what I found was that it still works very well for AI, even if it writes, as long as it's working on one feature, it can write multiple tests in one go, and it can make them pass in one go. And as long as you're careful and you double check them, that still seems to work very well, which might be a bit controversial because it's not true TDD. So it's why I think probably I should call it test first, because it's going test first, but it's not the same TDD. Do you know what I mean? But the value there, I would say it's those three things. It's restricting scope, verifying that it works straight away, and leaving you with that kind of regression step. And maybe the fourth one, having a natural point where you can say, okay, stop and let me check now. Well, I was going to add the mutation testing as well. And just a bit conscious of time, but I'll quickly summarize this one and then you can ask any questions. But the mutation testing, so again, for people who are not familiar with mutation testing, I used to do a manual form of this when it used to really annoy people that I was working with, because like I would have this habit of because a lot of people that I work with don't do TDD, right? And I do it and they don't, and it would annoy me because I'd always find gaps because they weren't, it's just natural if you're not disciplined about how you go about doing this, you leave gaps. And I would prove it by pulling down their, if I'm doing a PR of reviewing a pull request, I'm not a biggest fan of pull requests anymore, but regardless, if I'm reviewing somebody's pull request, pull the branch down, run the test. Usually the test will pass because it's in a PR and, these people are saying, have a look. And then I'd go in and deliberately break something that they've changed. So if they've got some logic that says, if user's age is greater than 18, do this, I will go in and manually change it to less than 18 and run the tests. And the amount of times you would see the test still pass because they've not caught that, they weren't careful. What mutation testing does is it basically automates that, right? So there's a set of rules, set of mutators, and it will go in and it knows, if this is greater than, I move it to less than, or I move it to less than and equal to, and this kind of thing. And then any tests that don't fail are called surviving mutants. And of course, you want to remove these surviving mutants. The downside to mutation testing, even though it's extremely powerful, is you've got frameworks like Striker, but it's very slow, right? Because it has to do all of this kind of mutation of the code, and it's just really expensive to run, to the extent that on a big code base, it can take like an hour or longer, So a lot of people will just run these tests overnight, which still adds value, I would argue, but it's not ideal. Maybe there's a way to kind of run it based on the diff, but I always had problems when I tried to do that. So what I tried was, I thought, well, maybe I'll just create a Claude skill and tell it that you're a mutation testing kind of runner. And I was a bit cheeky. It's quite, I think it's quite funny, really. But on the Striker website, they've got documentation that shows you, it has a list of all the mutators that they test against. So I just pointed that at Claude and I said, can you take these mutators and basically put them into a skill and you run mutation testing. So what it then does, it actually does that for you in real time. So it will go into your code, it will mutate, it will actually change those things greater than, less than, all of that, runs the tests, sees what fails, what doesn't, any surviving mutants, it reports them back to you. And it's even clever enough, though, to sometimes go, okay, but this one actually doesn't matter for this reason. Do you agree? And it usually gets that pretty much right as well. It's quite interesting. It has this kind of semantic understanding of the context. But yeah, so the flow that I now have is I go red, green, refactor, mutation test, and then I take a look.
It's interesting. A lot of things are interesting. I'm gonna again focus on the latest one. I've been playing with AI a lot as well. Although I'm realizing I have way more trouble than you to have it contained, even though I'm trying to make it do. I'm gonna say AI TDD instead of testing first, because I agree that it's really complicated to have the AI do just one test, because AI wants to write shit. And like, if it has a file, either you spend your day telling it, okay, remove the whole file you created, create only the first test, or you just embrace that, okay, it wants to create the file in one go, fine, do it and go ahead. And it felt like the natural extension to that is, okay, now testing is cheaper. And in most code bases I've been, and I actually talked to the creator of RSpec about it, I've had problems in the sense that the test suite takes about an hour to run. And it's like, okay, I can't really do TDD this way, even if I'm doing it with watchers. Like, if a test file takes 30 seconds to run, I just can't. But AI has helped a lot in tackling those big issues, in the sense that, okay, I want to systematically bring the time of execution of the test suite down without changing behavior. I can use AI for that, and to make big chunks of that go away, it's really helpful. So I've managed to get my tests to a manageable size, right? Like, now I have model tests, which are pure unit tests that run. I've got 3,000 assertions or 5,000 assertions that run in about 30 seconds. So that's manageable now. And I thought, okay, the next logical step is, let's do mutation testing, because I saw it as a way to ensure that the AI is writing tests that are safe, in the sense that, although I do review everything, I am human, and sometimes the eyes just gloss over the specs, because, I think it's testing the correct thing, but you never know. But I do have like 5,000 assertions. So if I'm running mutations on that, it's going to take, it takes about 2 hours to run. And so that's not scalable, right? It had never crossed my mind telling Claude, okay, when you make changes, here is the list of mutations you need to make, because the tests are actually fast. Like, I can run a test in milliseconds, and that's fine. And I had never thought about that. So that's something I'm already noting down.
Yeah, it's really powerful. And as I say, if you look in my doc files, you'll find the mutation testing skill, and it works extremely well. One other thing I would say, so one habit that I've gotten into is, so one of the problems with AI at the moment is sometimes this session is going really well, and then you'll hit this compaction event, right, where it compacts the context because the context is getting full, and then sometimes, like I've had it in the past, where it's going really really well, and then it just seems to have amnesia and it forgets what it was doing, and it's like you have to explain it all again. One of the things that I do personally, and I know there are like tools and frameworks to handle this, but I've never felt the need to use them so much because this just seems to work really well for me. Is I get it to create a plan document all the time, right? So, and the plan document is, the idea is that, and I tell it explicitly this, that it's a kind of work in progress plan as well, right? And the plan doc should have all the context it needs to be able to pick up with no context at all. So, put all the context you need to start again if you needed to. And then it has a kind of to-do list, but I always tell it, but we'll learn as we go, so expect to change and keep updating the plan doc, right? Because key to me is it's not just a TDD thing, it's like very kind of XP, like extreme programming kind of style, working small increments, right? So I come at it from a very opposite direction to people who are doing things like, the whole Ralph Wiggum thing where you leave it running overnight and expect to come back to a running app. I just think that's, while it's kind of cool and stuff in a way, I just think for real production apps, that's a nightmare, because I just like, how are you going to, I can tell you, even working this way, to be clear, it's very interactive and I still find issues. It's not perfect, right? It's there are times when I read through and I'm like, even though it's got all the context and instructions, it's naughty and it tried to cheat in a test, right? And I'm like, no, what you do? And I tell it off. Do you know what I mean? I'm like, no, you shouldn't do this. Remember not to do that. Sometimes it might try and go off and do the wrong thing or whatever. And it's extremely good, but I still feel very much like I'm the one leading it. Do you know what I mean? And I'm directing it. But what I just wanted to say, so I recently updated my doc files to. I'll share my screen again briefly, but I'll explain what I'm doing while I'm sharing this with you. So I have, for example, this planning skill. So again, for people listening to the podcast, I'm just showing my screen here, which has got my doc files, and this is a planning skill here. So I'll just read. I'm not going to read the whole thing, but just to give you some idea. So it says all work must be done in small, known good increments. Each increment leaves the code base in a working state where all the tests pass. Bear in mind, this is my plan document that always is created as I'm doing a piece of work, right? Prefer multiple small PRs. Break work into the smallest independently mergeable units. Each PR should be reviewable in isolation and deliver a coherent slice of value. Then I've got things like what's quite useful here. So I explicitly tell it, and this has improved the TDD kind of adherence in my experience, because it reads from this plan document and I have TDD integration. Every step follows red-green refactor. It should mention mutation testing in here as well. Yeah, it does right at the end. See here. Actually, this is slightly wrong. I should have this. I only updated this very recently, but what it says right now is pre-PR quality gate mutation testing, but really it should be at the end of every red-green refactor step. But what I found is that by incorporating that into the plan document itself, it seems to help it, because my thinking is that it's reading from that document as it goes, and it keeps kind of rereading. No, you have to do TDD for this. And do you see what I mean? And it seems to work. I guess while I'm sharing the screen, I'll just quickly show you the mutation testing one. Might as well just show you that as well. So that's here. On this one, again, I won't read all of it, but I'll just go through. Where are we? So like you can see here, so I've got like mutation operators. And just as an example, it says like arithmetic operation mutations, and it's got like original says A plus B, so mutated is A minus B. Test should verify additional behavior, subtraction behavior for others, and so on. And then it's got some examples, and these all come out of the. These are all from the Striker docs. I just literally took them and, and then I think towards the end somewhere I tell it to basically create a kind of report and see here as well. The key question for every line of code: if I introduced a bug here, would my test catch it? But again, what's really interesting here, and something that you can't do with the traditional tools, is it's capable of understanding semantically what the code is doing, not just syntactically, and therefore it provides it gives a kind of report at the end. But quite often it'll say, because you don't always need absolutely 100% on these things. There can be the odd thing that it's actually okay, it doesn't matter, or do you know what I mean? And you have to apply a bit of judgment. But it's also sometimes where it finds gaps. It not only finds the gap from a code level, it will then go back and it works out, okay, but what was the behavior that I'm missing by not having, but by that mutator surviving? And then it'll suggest, no, I'm going to add a test for this business behavior and lock that in. Do you see what I mean?
Yeah, it makes sense. The example I have in mind, which is a very Ruby example, but you have this dot presence method that you can call on an object that might be nil or something. And basically dot presence will either return nil if the object is nil, or the value of the object, right? Like I've got a hash and I'm checking for a key and I put dot presence. That's a mutation that most likely kind of needs to survive, because if I'm passing the key and I remove the dot presence, the test won't catch it because it's not really testing behavior. It's more doing defensive programming than anything else, right?
Yeah. It's hard for me to think of an example, but I've seen a few recently similar to that, where it's like you can look at it and just apply judgment, and it's like, okay, that one doesn't matter. But yeah, but it's overall, I will say that following these patterns, and there's a bit more as well. Like I've been experimenting with. We haven't got time to go into all of this, but I've been experimenting with hexagonal architectures and domain-driven design and stuff like that. And I'm finding that really interesting and useful as well. But generally, this is kind of how I'm applying these techniques, and it seems to work extremely well.
It does feel, because now you're mentioning hexagonal architecture, and it does feel like all this new again. Like I have this pet peeve. One we glanced at whilst we were talking, which is that some concepts just get watered down or get changed, and now people say TDD and they hear unit testing for reasons that have nothing to do with nothing. And then some things are just not caught on, right? You were talking about XP, and when I was looking at your skills, and again, I will link them on the show notes, a lot of it is reminiscent of, okay, AI work as if you were an XP practitioner, right? Like small increments, tests always passing, some amount of BDD, although I do think that came later, but it was kind of there in the XP book. And it does feel like all this new again with AI, in the sense that a lot of people that I see and follow that are being successful with AI are following, I'm going to say known best practices, but the known there is doing a lot of work, because I feel like a lot of people don't know them actually.
I think it's really fair, and it's a funny one, because it feels in some ways to me like, I don't know if it's quite right to say that there's a kind of a bit of a battle going on right now, but I see a lot of noise online where a lot of people are saying, oh, AI just doesn't work at all. It's just, it's all hot air. And other people saying, oh, well, the solution to AI is basically going back to pretty much waterfall, and it's big design up front, and you have to get all your specs right again. And then there's people like me who are doing the exact opposite and saying, no, actually, if you try using XP, it just, these techniques, it massively accelerates you. And I think what you're seeing is, what I would hope is that we're going to see the rise of these techniques again. And this time, hopefully, we'll actually kind of win overall, because I think these techniques have always worked extremely well, right? They have, but they were not widely practiced, which I think is a massive shame to the industry. And there's a whole, like, you could talk for an hour on why that's the case. You could talk for longer. But what I think is happening now is that this stuff is becoming a lot more visible, because people like me are suddenly building stuff at a rate that is just was previously unthinkable, and in a sustainable way. that's the key difference. So you see even people like, and again, I was going to say like Amazon recently had a big thing where they're saying senior developers again have to sign off anything that's done with AI, which I think is just the wrong approach. But I suspect that the Amazon devs, I've spoken to a lot of people who work at places like Amazon in the past, and a lot of them push back to me on things like TDD, saying, "Oh, we don't do it here," and almost using a circular argument to say, some of them were almost arguing, well, because we don't do it here, we don't do it here. We would be smart enough to be doing it, and because we're so super smart and we don't do it, that means that it mustn't be a good thing to do. And it's like, well, no, that's just circular logic, right? And it doesn't surprise me that a lot of companies and people are finding that it isn't working for them. But I would hope that they would pay a bit more attention, and hopefully they will, to people who are trying a different way and using these techniques that are kind of battle tested, and actually are reporting success back. And to be clear, it's not 100% perfect in every way, but I'm finding that I'm going at a pace that I've just never thought possible. Like I'm building now this kind of micro SaaS framework in my own time, right? Just to give a bit of context about that thing, I'm building it in a way where my mental model for that was I was thinking, well, now is probably a good time for somebody like me to try and capitalize, because right now AI is super powerful, but it requires like engineering skill to really do properly, right? Anything more than a prototype. Maybe that won't be the case in a few years. I don't know, right? But right now it is. And so I thought, well, if I'm going to try and make any money, now is probably the time, right? So I started thinking, well, what if instead of just building one product, what if I built like a framework that allows me to pump out SaaS products quite quickly? So if I can get to a point where I could do, say, one a month, something like that, that would be amazing, because pump out 10 a year, whatever, roughly, if just one of them sticks and makes a bit of money, then great. Do you know what I mean? So I started using principles based on similar to kind of hexagonal architecture, really. It's kind of slightly different because of how it works in the hub, but the concept is basically the same. It's like ports and adapters, right? So the idea is, I refer to it as capabilities. So you think about a SaaS framework, a SaaS product. SaaS products typically need certain capabilities, right? So you need auth, you're going to need payments, you're going to need newsletters and emails and notifications, that kind of thing. So I create these ports, these interfaces for each one of those things. So for example, there's a payment port, right? And then you create an adapter. So then I've got like a Stripe adapter. And so then I can say, okay, I want to build a new product. I'm going to use Stripe for that. So just pull in the Stripe adapter, and then I've got payments, right? Now, that's a complicated thing to do well, right? In the space of, it's probably taken me, realistically, probably been a couple of hours, probably more than a few hours a week, but over the last month or so, maybe 2 months, I've built out a framework now that has payments in there, that has notifications, emails, all of that stuff. And I've almost built the first product. I've got it's actually online, but you can't register to it yet. I don't know, chipping.online. There you go. You can, but you can't actually register at the moment and so on. But the point is, this is just a product that I'm building to prove out the concept, right? To prove that concept. And the amount of work involved in doing something like that, it would take a team of people a lot of thought and effort. It's easy to say I'm going to have a payment interface that can be shared across different products, but actually making one that would work is really hard, right? Mm-hmm. But what I did was for the payment interface, I got Claude to do some really in-depth analysis, and I said, go off to Stripe, go off to, I think the other one was Lemon Squeezy, and I want you to work out how to create an interface that would work for both of those use cases, and produce a document that shows all these methods and stuff that you're creating in this interface, link them to the exact area in the respective docs to prove that would work, right? And it did that. And then I said, okay, now I'm going to get you to create this Stripe adapter. And it created the Stripe adapter for that it took about 45 minutes of it going back and forth. And then I wired that into my app, and I tried it in the Stripe sandbox, and it worked. It just worked first time. That kind of stuff working in this way with the tests and all of that in place, it's a sustainable way of doing it. And I'm working in a way that would take, I think, legitimately a team of skilled people would have taken a while to have done that, working on it full time. Do you know what I mean? And I'm already at the point where this and I've got auth working as well. I've got my own, like, I'm using Authentic as an auth provider, so I've got that working, and all the tests are working, and it's I'm just at the point now where the only thing I actually need to do is to flesh out that first product, and I'm just working on that functionality now. And once I've got that done, the first slice is done, and then I can increment build on top of it, but then I can build other products using that same setup. Do you see what I mean?
Yeah, I see what you mean. It's really interesting. Yeah. We are past the allotted time. I have 1,000 questions, so I'll probably try to get you back here soon, or as soon as your schedule allows it. I do have one quick question. At what cost would LLMs not be worth it anymore in terms of the help they're providing you?
When you say cost, how do you mean? Do you mean as in money?
How much per month? Yeah, how much money per month?
I can tell you, I pay for the 20-time model Claude now, so that's about £180 a month. And I almost don't want to say it because I'd hate people at Anthropic to hear these things, because to me it feels like a bargain. It feels like an absolute bargain right now. I would say that right now I'm getting way more value than I'm paying for. I would definitely pay £1,000 a month for it, definitely. If I was actually in, because right now it's not a product that's making me money yet. Hopefully at some point it will do. If I was in the position where, because I'm quite lucky, it goes through my business as well because I'm a contractor and stuff. But if I was in a position where the product itself was making money and enough to pay for itself, let's say I could cover the costs with what's coming in, I would probably pay more than that, even like $2,000 a month, $3,000 a month. I mean, it's a lot of money, and I understand it's a lot of money. And the problem is that, you go too far and you'll get to a point where, normal people, everyday people who aren't making money for a business or so on wouldn't be able to pay that. But in terms of if you look at it a slightly different way, I think if I were working on this thing full time now, if I did, because I have a full time contract that I'm working on, and I have 2 kids, so I can't, even outside of working hours, I can't work on it all the time. But if I worked on it full time, I reckon, first of all, that product would have been out weeks ago, and I would say that I'm doing more work than a team of skilled people a few years would be able to do in I'm probably working 3-4 times faster, maybe more than that, than a team of skilled people could have done just a few years back. So if you think about it that way, how much you'd be paying those skilled individuals every month, suddenly, you're talking in realistic terms, like even paying like $10,000 a month might not be over. I mean, obviously I'm not saying that I would be, but if you look at the maths in that way, do you know what I mean? It's, I don't know. Maybe I'm saying stuff that's controversial there. I don't know, but it's
no, it's a genuine question that I have of, I don't know at which price point it stops being valuable to me. Because what I'm hearing is I would be willing to pay a lot of money as long as I had a poll there.
Well, I mean, that is the thing, I guess. There's definitely a kind of skill involved in using it. There's a learning curve in it. And I think it does take experience right now. Yeah, so for me personally, I'd probably go up to about £1,000 now. And I'm lucky enough to be able, my business could cover that for the time being. And it's kind of worth it for me because I'm trying to build a thing. But I see what you're saying. And we're still at this point where not everybody's getting this value. And I think hopefully, people experiment with these techniques. You might find that, more and more people start delivering on the promise.
Cool. I've held you way longer than I should have. I apologize for that. It was a really, really interesting conversation. As I said, I'll try to get you back if you're open to that. In any case, thank you very much for a very interesting conversation.
Yeah, no worries. Thanks a lot.